This is an Algebra 1 Regent question from the August 2014 Regents. It's question number 20. There's more than one way we could solve this equation. We'll go through 3 of them. The first way you could do it is the way that the Regent actually wants you to solve it, by solving it algebraically for x. So let's look at the question. X minus 2 over 3 plus 1 over 6 is equal to 5 over 6. And we want to solve this for x. The first thing we want to do is get rid of these fractions. We want to just be left with numerators. We don't want to have to deal with fractions. So the first thing we could do is try to give x minus 2 over 3 a common denominator so they all have the same denominator of 6. Let's do that. We multiply 3 by 2, then we'll get 6. We can't just multiply the denominator of a fraction by 2. If we do it to the denominator, we also have to do it to the numerator. If we multiply the numerator and the denominator by the same thing, it's as if we multiplied by 1. Why is that? Let's say we have 4, and we're multiplying it by 2 over 2. 2 over 2 is really equal to 1. So what we're really doing is multiplying 4 by 1, which is okay. So 4 times 2 over 2 becomes 8 over 2, which is really 4. So 4 is equal to 4 even when we multiply it by 2 over 2, which is 1. So here we can multiply 2 by 3 as long as we multiply the numerator also. But we're going to have to distribute the 2 in the numerator. Since it's a binomial, we have to distribute it over the x and over the negative 2. So 2 times x is 2x. 2 times 2 is 4, so it becomes 2x minus 4 over 2 times 3 is 6. Then we have to bring down the rest of the equation. Plus 1 over 6 is equal to 5 over 6. Now, since we have all of these, we have 3 fractions, they're all over the same denominators, we could just ignore the denominators. We could totally just get rid of these denominators and be left with the numerators and solve it like a regular equation. 2x minus 4 plus 1 is equal to 5. We could, since they all have a denominator of 6, we could just get rid of those denominators. And let's solve it. Let's combine the constants on the left-hand side. 2x minus 4 plus 1 is minus 3 is equal to 5, and bring the 3 to the other side. Plus 3 and plus 3. Cancel out the 3 on the left-hand side. 2x is equal to 5 plus 3 is 8. 2x is equal to 8. Let's solve for x by dividing away the 2, and x is equal to 4, which is choice 1. Now that wasn't too difficult. What you want to notice is that if you have fractions that all have the same denominator, you could just ignore their denominator. Now that doesn't apply when you have, let's say, numbers. Let's say you have 5 over 6 plus 1 over 6. You want to know what that equals. You can't just ignore these denominators and do 5 plus 1 is equal to 6. When you have numbers 5 over 6 plus 1 over 6, you have to do 5 plus 1 is 6 over 6, which is equal to 1. But when you have variables, when you have 5 over 6 plus x over 6 is equal to 1 over 6, then you could ignore the denominators and just solve 5 plus x is equal to 1. Another way you could have done this is by plugging in the whole left-hand side of your equation into y1, by graphing it into y1, and graphing the whole right-hand side, which is just 5 over 6, and y2, and checking where they intersect. Wherever they intersect, that x-coordinate of that point is what x is equal to. So let's do that. Alpha y equals, to get a fraction, the numerator of our fraction is x minus 2. Let's go down to the denominator, over 3. Next to the fraction, we're doing plus another fraction, alpha y equals, to get another fraction, 1 over 6. And now let's go down to y2, and we want to have 5 over 6. Now, if we press zoom, we could see what we want to do is, what we press zoom 6, that will give us zoom standard. Zoom standard means that the maximum x is 10, the maximum y is 10, the minimum x is negative 10, and the minimum y is also negative 10. This is a standard graph. If we see that our intersection point is way off the graph, like over here, then we might need to adjust our window by going into Window and adjusting the window. But let's first see if we could graph it in Zoom Standard and see what happens. Zoom, you can either press the 6 or scroll down to the 6. Let's press the 6. It'll give us Zoom Standard. That's the first the left-hand side of the equation. It's the right-hand side of the equation. And we see that they intersect nicely in Zoom Standard, so we don't have to adjust the window. Now, we don't know exactly. We see that they intersect somewhere over here, but we don't know exactly where that intersection point is. If we go to second trace, you'll see that over the trace, there's a little calc word. So when we press the second button, the blue button, we're really activating the words in blue, so we're in the calc menu now. In the calc menu, let's scroll down to 5, intersect. Press enter. Now the calculator will tell us where they intersect. They want to know which curves we want to intersect. Let's say we have 5 lines here. They want to know which curves are we checking to see where they intersect. So the first curve is this blue curve. And we see that our cursor is on the blue curve, so press enter. They want to know the second curve. Now our cursor moved to the second curve, so let's press enter again. Guess. The calculator wants us to guess where we think it is, where we think the intersection is. So let's scroll over there. Somewhere right over there. You don't have to be exact when you're guessing. The calculator will figure it out. Press enter. The calculator is going to calculate where the intersect is. They tell us that the x-coordinate of the intersection is 4, which is what we found when we solved it algebraically also. The answer is choice 1. That's how you would do it graphically. The last way you could do it, let's do second mode, or quit. When we press the second button, we activated the word in blue, which is quit, to get back to our blank screen. Now, if we set x is equal to, we're going to try out the answer choices. So let's assume that we don't know that the answer to the question is choice 1. If we have the calculator, we set for store as alpha. If you see in green, there's a little x. That means when we press the alpha button, we're activating that little word, that little letter in green. So when we press go again, we're really typing in x. We're setting 4 is equal to x. Let's press enter. Now, whenever we type in x, the calculator is going to evaluate it as 4. So if we type in the whole left-hand side of the equation, with x being equal to 4, if that equals 5 over 6, then we got that. Then the answer is x. So let's do that. Let's do a fraction. So alpha y equals, enter to get a fraction. Then we're going to do alpha stow to get an x, minus 2, right arrow to go down, over 3, plus alpha y equals, enter to get another fraction, 1 over 6, enter, 5 over 6. So since when we plugged in for x, we plugged in 4, and that made the equation correct and equaled 5 over 6, we know it was correct. Had we done 6 stow alpha x, had we stored x as 6, then the equation would not have made sense. Let's try that just to be sure. So here we could copy our equation down, but now we change what x is. Before we stored x is equal to 4. Now we stored x is equal to 6. So when we evaluate it, we're going to get something different. Let's press enter. We get 3 over 2. 3 over 2 is not equal to 5 over 6, so choice 2 is not the answer, and if you would try choices 3 and 4 also, they would not work.